Hello, welcome. This is the next FP1 tutorial, obviously. This is on an introduction to matrices, adding and obviously subtracting them, okay, and multiplying them by a scalar, all sort of jammed into one video. The reason I've done that is, well, matrices is just a very simple, the first bit is very simple anyway. Well, what is a matrix? We talk about this thing, well, just mentioned it. You might go, what the hell is it? Well, it's just an array of numbers, okay? It's just a series of columns by a couple of columns and a couple of rows of numbers, okay? So you could have something like this, which is 2, 7, 8, 6, okay? That's what we call a 2 by 2 matrix. What we mean by 2 by 2, it would sound like, apart from sounding like a builder, is the number of rows times the number of columns. And just to clarify, rows, so we'll call this row 1, row 2. Rows go horizontally, okay? Columns go vertically, okay? Alright, so therefore that has 2 rows, 2 columns. Okay? So that's what we mean by matrices. Now you can have varying types of matrices. It might not be 2 columns, 2 rows, 2 columns. It might be just 1 column and 2 rows. Okay, so it might be just 2, 7. Okay, that would be a 2 row, 1 column, 1 column matrix. Sorry. Okay, so we'll go on to the reason why I said vectors is because later in this topic we do some relation to vectors. So we'll come on to that, but really that's sort of what a matrix is. There's nothing more to it, okay? It's just the number of rows times the number of columns, and it's just a way of setting out a couple of numbers, okay? Right, so that's what a matrix is. If I even said that right at all. Okay. So now we're going to go on to adding, subtracting them, and timing them by a scalar. I think the easiest one to do is obviously to times by a scalar, okay? So we'll call this a matrix A. Now they're normally denoted by a capital letter, okay? Okay, so we'll go back to that 2, 7, 5, 3, 1, okay? And if we're asked to find out what 2A is, we just do 2 times individual parts, okay? So we do 2 times this top left 2, 2 times the bottom left 7, okay? So 2, 14, 2 times 5 is 10, and 2 times 3 is 6, okay? So it's just 2 times the individual parts. And this is very similar to adding a matrix, okay? When we add 2 matrices together, so we'll call this A, okay? So we'll do A as 2, 7, 5, 3 again, and we'll do B as 6, 5, 4, 1, okay? So when we do the matrix of A plus B, we just add the like terms. So just like when we did the vectors with I, J and K, okay, you wouldn't add an I vector with a J vector. It's kind of the same thing if you can imagine it like that, okay? So we do 2 plus 6, okay, which is obviously 8, 5 plus 4, which is obviously 9, 7 plus 5, which is obviously 12, just think about that for a second, 3 plus 1, which is obviously 4. Okay, so that's your matrix of A plus B. As you can quite clearly see, nothing too challenging. And if we were to do A take B, okay, we just do the opposite in terms of we take the like terms. Okay, so it would be 2 take 6, which is minus 4, 5 take 4, which is just 1, 7 take 5, which is 2, and so on, 3 take 1, which is just 2 as well. Okay, so that's adding and subtracting them and multiplying them by a scalar, all in a very short period of time, okay? So that, as you can quite see, is very, very easy. So just make sure I've not missed anything out. Sorry, I do apologise. Yep, that's pretty much it, okay? So what time are we on? Sorry. I guess what I'm going to do now is I've just put a few questions on the board because it's only 4 minutes long so far, and you can have a go at them. Alright? So just to recap, a matrix is a row of numbers and a row of numbers and a row of column. Sorry, a column and a row of numbers, and when you multiply it by a scalar, you multiply the individual parts of the matrix, and this ends up being a matrix, okay? So you just times the individual parts, okay? So if it's 2A and A is 5, 6, 7, okay, you would do 2 times 5, 2 times 6, 2 times 7, and 2 times whatever the other value is that I've not mentioned. Okay, so that's really kind of a very quick summary. Alright, so the first one I'm going to ask you to do, so add these two vectors together. No, I do keep saying vectors. So 5, 7, 2, 1. And you add that to 3, 1, 2, 6. Okay, so we'll call that vector B. And then we'll do them two take away each other. Okay, so it's A take B for number 2. We'll call these two vectors A and B. Why do I keep saying vectors? I need to shut myself up. And then 3, well, you can do 2A. And then 4, describe what this vector is. So 2, what vector? God's sake, this is why it's easy to get confused. Describe that matrix in terms of is it single column, single row matrix. Okay, so just give you a few seconds to pause the video, and you can have a go if you want to. Right, so hopefully you pause it, but hopefully, otherwise you won't be listening to me. You get the idea. Okay, so it's adding like terms. You do 5 plus 3, it's 8. 2 plus 1, which is obviously 3. 7 plus 2, which is 9. 1 plus 6, which is obviously 7, and that is your matrix. Now we're going to take them away, do the same principle, but take the like terms. So 5 take 3, it's obviously 2. 2 take 1, it's obviously 1. 7 take 2, it's obviously 5. And 1 take 6, it's minus 5. 2a, well, you just 2 times the individual terms, okay? So it's 2 times 5, which is 10. 2 times 2, which is 4. 2 times 7, which is 14. And 2 times 1, which is just 2. Okay, and number 4, that is a single column matrix, or a 2 row by 1 column matrix. Okay, because we've got, say, columns go downwards. Okay, so we've got 1 there, and then we might have another few. Rows go horizontal. Okay, so we've got 2 layers there in terms of 2 rows. Alright, so as I said, that was a very, very quick introduction to matrices. In the next video, we're going to be looking at multiplying a matrix by another matrix, which is a hell of a lot more challenging than simply timesing a matrix by a scalar. Okay, and we'll go on to looking at why that is, and I'll be referring to something called a dot product, which the principle remains the same, but obviously we're using it for a different thing than we would do, if you were going to do C4 vectors. Okay, so thanks for watching. As I said, sorry if it's been so short. I've had obviously a few comments recently about my videos being far too long, so, you know, listen to the consumer, even though they're not actually paying anything, so I can do whatever the hell I want. I can even do a little dance. Anyway, so thanks for watching, and we'll see you in the next video.